Welcome back, everyone. So we have a continuation of our Chapter 8, Quadrilaterals. 8.1, we studied the parallelogram, and now in 8.2, we're going to be studying the rectangle. Now, the rectangle is really an upgrade from parallelogram. So the rectangle has to have all the parallelogram properties first, and then it gets either a right angle. Now, you might question, well, what about, I thought it was 4 right angles. Well, as soon as you have one right angle in a parallelogram, all 4 have to be, because if you take the parallelogram properties we studied, opposite angles are congruent. So if that's a right angle, then so is this one. Oops. So that gives us actually 2 right angles already. And then if that's a right angle, it measures 90 degrees. Now, in a parallelogram, consecutive angles, the ones that share a side but not a vertex, have to add to 180. So if one of them is 90, the other one's 90. So that forces all 4 of them to be 90. So yeah, the shortcut is to say that all 4 angles are 90 degrees, and that makes a rectangle, or a parallelogram with one right angle has to be a rectangle. The other upgrade is when you have a parallelogram, the diagonals at least bisect each other. Now, what I mean by that is, this would not be a rectangle, by the way. What I mean by that is, if this one's 10, then that one's 10. If that one's, say, 8, then this one's 8. Now, this would not be a rectangle because it doesn't fit another property that's required for a rectangle. So this would not be a rectangle. It would be a parallelogram because the diagonals bisect each other. To upgrade from parallelogram to rectangle, what would simply have to happen is the diagonals would have to not only bisect each other, but they'd be congruent. So we signify that either by putting a slash on all of them or saying they're all the same measure. So all the pieces of the diagonals are all congruent. All right, so now let's go through your notes. All right, I made a few statements on the notes. What I'm doing is going back through the parallelogram, simply because that's essential to moving on to the rectangle. So let's start with this. If they tell you ABCD is a parallelogram, what we could say as a statement is AB is parallel to CD. Now I want you to make that mark. The way we mark parallel, be careful please. Parallel is with an arrow. We'll get to congruent in a minute. Parallel is an arrow. Now you're seeing me show a double arrow because it's a different set of opposite sides parallel. Now, you want to be able to write this. Why is AB parallel to CD? That's because both pairs of opposite sides in a parallelogram are parallel. Next statement. If I tell you this is a parallelogram, you could tell me AB is congruent to CD and ED is congruent to BC. Notice the difference in marks. It's not an arrow, it's a slash. That's how we show congruent in our course. Why are those congruent? Because both pairs of opposite sides in a parallelogram are congruent. Make sure you use the right word. It's very easy to say the wrong word because they're congruent and they're parallel. So make sure you say the right word to justify your statement in proof. All right, statement 3. Now, AE is congruent to CE. All right, what we're trying to show here, and again, it's a slash for congruent. What we're trying to show here is the diagonals bisect each other. Okay, diagonals in a parallelogram bisect each other. Those properties, when we upgrade to rectangle, all hold. So I want to go through those. Let's see. So angle DAB is congruent to, don't know what happened. Looks like it just took over. I must have hit something. Hang on 1 second. Back to this. Hopefully it's still recording. Okay. So angle DAB is congruent to angle. Okay, so that's this. I'm going to show this one off to the side. We don't need the diagonals in there for this one. So DABC. Okay, so what we're doing is we're taking this picture and going over here. DAB is congruent to DCB. Okay, what we're trying to show is opposite angles in a parallelogram are congruent. So we didn't need the diagonals for that, so that makes it a little simpler to look at. Okay, keep going. Okay, so what this is going to show, again, we don't need the diagonals. Okay, so this angle and this angle are supplementary. I'm not going to mark those. There's no marking for supplementary. I'm just identifying which two angles we're talking about here. Those two angles. Those are consecutive angles. Not sure if you've ever seen consecutive, so I want to show the difference here. Consecutive angles share a side but have a different vertex. Now, that's different than adjacent angles. Okay, adjacent angles, so here's consecutive, right? They share one side but have different vertices. Okay, now these two, so that's actually these two. All right, these two are adjacent. Now, what makes the difference is they do share a side as well, but they share a vertex. So adjacent share a side and a vertex. Consecutive share a side but different vertices.